Let me try to explain what I'm trying to do here exactly and why I was cutting those pieces of material in the first part of this video. They're pieces of Starrett flat stock, 3/4 of an inch thick, and they're going to ultimately be made into these drilling guide plates for the gun, in this particular case the gun drills that I'm going to drill this part with on the holes on the end of the part. And I thought I had previously made this fixture for a very similar part to this that has almost the identical end detail in it, but in studying the CAD model I had made of this fixture when I built it, this was I actually made a video on this, but I had to take it down at the customer's request on this issue here, and it didn't have to do with this fixturing. It had to do with he didn't want the whole part being seen, I guess. I don't know, but this particular part is the same end detail almost, and I thought, oh, I already had this fixture made, except this clamp ring isn't the right size and it wouldn't fit on the part that I'm dealing with now. It has to be bigger in diameter, which means that these holes, these mounting holes, wouldn't work here. But I thought I could accommodate that by clamping it in a different method onto the part and holding it in there, and I thought, oh good, I got something that's already going to work for me, and I don't have to remake this thing or make a new one. But when I was studying the CAD model and trying to line this all up, I found that they changed one little thing on this. Well, actually there's two different things, but one of them I could have accommodated by machining another keyway. See, this is the drill plate for the first set of holes that goes down in the bottom of this bore. And really the reason I'm doing this to begin with, I guess I should explain that, is this distance from here to here is about 5¼ inches. And these holes are off center inside the bore, which you'll see in a second here with the CAD model, where I'm going to show you why I had to change this whole thing. And to get them on location down there at the bottom of this counter bore that's kind of deep, and also you're close to the side, so you can't use a big diameter tool to get in there. And you got to go in there with many tools. You have to go in there with a spot drill, then a drill, then maybe something else. And in the case of the ports, you'd have to go in with a form tool and various things. And it takes quite a bit of tools. And the part I did before, like this, worked so well that I'm just going to do the same thing here. But unfortunately, this same fixture won't work. And the reason it won't is they've moved one hole. This hole pattern here lines up perfect with the new part, except that this hole here, these two holes here, I should say, are for these dowel pins to line these fixtures, the drill plates, if you will, up on the end of this fixture. And the way this lines up is with the key. There's a key that projects out into the bore, and if you had watched my previous video on making the shaping tool to shape this key in there, you would kind of understand that. But I'll show it again when I show the CAD model part of this video. But this hole here is over here on the new part. It's over on the other side. Just this one hole. These three holes are for 832 screws, or threaded holes, I guess. I don't know, maybe they put screws in there, I'm not sure, but these three holes make 832 tapped holes, if you will. And this is the tap drill size, which I'm actually using a gun drill and coming all the way from the other side of the fixture to drill those holes. And this works quite nicely because it guides the drill in just the right location and everything. But unfortunately they moved this one hole because they have the key, this key, over here in this orientation on the new part, right in this area. And when I first saw this, I thought, oh, I could machine this and I could just modify this fixture and machine another key notch in there. But in reality that's not going to work, because it's going to intersect this hole. This flat has to rotate all the way around here, and it would be over here, and it would intersect this hole, and so this fixture would be kind of messed up for using it on the other part, which I may do someday in the future. So I don't really want to modify it in that way. I thought the key was going to be in here somewhere, and I could do this, and all this whole pattern was the same. But the fact is they moved that one hole, but everything else lines up with this drill plate. And of course this one would also line up, because these holes here, this whole pattern is the same as these. The only reason these are bigger is this is where the port sizes are. And what I found in this titanium material was I could gun drill this smaller set of holes first, and the 3 holes for the tapped holes, and then I pull this out and I change to this drill plate, and I stick the thing back in, and it orients on the key, so that clocks it correctly to everything. And then I could gun drill these holes in here. Now these ports have a they're actually 0.438 diameter, and they have a I think it's a -0 + 1/1000 tolerance on the diameter, which the gun drill holds fine, and also a 32 finish, which the gun drill holds fine. And all I have to do is drill it with a standard gun drill, and then come in with a flat bottom gun drill that has the 30 thousandths tip radius on it, and it makes the port with just those 2 tools. And then I have a form tool that I've already ground that I can reuse from this part setup that puts a chamfer on the hole and a spot face. So that would all work fine with this fixture, except for this issue of moving this one hole over here, and then the key is in this area that interferes with this part of this fixture. So I have to build a whole new fixture with drill plates. So what you just saw is me sawing this Starrett flat stock to make these out of, because I want to prepare. You have to think about the order of operations when you're doing a machine job like this in the fixture, and I want to prepare these blanks, and they can even be square at this point because I can mill them and turn them round on the intergrex. But I want to prepare them with the 2 dowel pin holes and this hole for this 5/16 18 screw that holds them on here, before I do all this milling and turning on the intergrex, which is what this video is actually going to be about, is making this piece right here, the new one. And then I can screw these parts on top of here in their rough form, which they'll just be squares out of that Starrett flat stock. And then I can but I'll have put these 3 holes in them over on the horizontal mill, and then I can mill them round and mill the keyway and everything when they're mounted on the proper orientation on the new fixture. So let's look at the CAD model, and I can kind of give you a better idea of what I'm talking about in the way these holes almost line up, but they won't quite work. Here we're looking at the CAD model on the end of the part here. I'm going to look directly down on the end of it here so we can see what's going on. Now if over in this part in the drawing, I've drawn or I actually imported the old model of the old fixture into here so I could kind of look at things. And so here's the drill plate, the first drill plate of the old fixture, and you can see this hole here. I kind of highlight that surface below. This is where that new 832 hole is, right over here, and the old one was over here, and you can see the key and the bore of the part that I'm fixing to make now is way over here, and it would interfere with this part of the fixture on the old plate. So if I turn this off and on, you can kind of get an idea. See, you can see the difference. So the new drill plate has to look like this, with this hole over here and the key slot over here. But unfortunately, you know, I can't use the old fixture because of that one issue. And see, here's the second drill plate, like you saw just a minute ago in the video. And these 2 holes here, of course, are the dowel pin holes that I mentioned earlier. So this is part of the whole reason I have to make a whole new fixture here. The end of this is going to also have a ring to clamp around the end of the part here. But other than that, this fixture is almost identical. This slot here in the fixture, let me turn this into so it's not transparent here and we can see it. This slot here is just for indicating purposes, as well as this notch here, just to make sure, because actually this thing is going to sit, if I can grab something and rotate it here. So I would indicate this horizontal to get the fixture lined up in the part, or the actual program lined up to the fixture. The fixture itself will line up in the part because of the key that's in the bore here, right here, and this is actually going to line up on this drill plate. Unfortunately, like I said, I can't really use the same fixture. I kind of thought I would to do this, but I can't. We're going to attempt to do a voiceover. I'm running a horizontal mill behind me here, so you might hear some background noise of that machine. Here's a facing cut on the fixture stock with CNMG 432 insert, 500 surface footage, and 12,000 speed. This is a little bit high surface footage for this piece of material. It must have had a heat treat to it. I just found this drop by the saw, so I was using it. Taking 150 thousandths depth of cut on the radius as well. And here I was really so intent on making my video, recording the clips and everything, that I wasn't really paying attention too much here. And you'll see in a little bit here on, I think this pass right here, I actually run into the chuck jogs with the spindle face of the machine right about here. I'm like, whoa. So I stop everything and look and see what the damage is. And that's where it hit the jaws, right on the corners of those jaws right there. Because I was paying more attention to the video when I should have been paying attention to that. So I decided here to try to file it off, but whatever they make that spindle face out of is hard. I couldn't file it. I couldn't even touch it with the file, or it got hard when the jaws hit it. Anyway, I ground it with the angle grinder and a little Scotch-Brite, and it wasn't too bad. It just a little bit more than that chamfer they put on there. It just barely hit it, really. But if I'd let it take the next pass, it would have hit it big time, because it's 150,000 deeper on the next pass. So I thought I'd better figure out how much I need to move the part. Decided to move the part out in the chuck, because it was still being roughed, and there was stock to come off of it. So even if it didn't run perfectly true, it'd still be fine. So I was looking at how much clearance I needed here. It seemed like about 5/8 of an inch or so would give me plenty of clearance. So I thought I'd just move the part out right now while I'm at, be the best thing to do. And here I was just taking a level and kind of tapping the part to make sure it was sitting level still there. When you indicate something in the 4-jaw chuck with these serrated jaws like this, here I'm just changing to tool 80 because I use that for the indicators, as well as it's already set up with the offset for the hammer probe, because I'm going to have to retouch the Z off. But like I was saying, when you indicate something in these serrated jaws on a 4-jaw chuck like this, once you get those jaws tight, you can't really move the part if it's not sitting square to the chuck. So it's best to get that square first, is what I'm doing here, kind of indicating it back and forth, tapping it around till it's running straight out parallel to the Z-axis, and then start indicating your run out. If you try to do it the other way around, you're not going to be able to, with these serrations, it digs into the material and you're not going to be able to move it no matter how hard you hit it. If you're using smooth jaws, or soft jaws, you could do it the other way around, but not with these serrated jaws. I found that it's almost essential to get it running, straight out of the chuck first, and then indicate your run out. So this seemed like it was good enough because there was stock to come off still. So I got to retouch the Z off because I moved the part out, and I set it so that I had about 30,000 stock to face off, so that I was sure it would clean up on the faces. So here's the facing cut. See, it's taking a little bit more stock off the faces. And then I ran this pass and the next one and stopped it, and then I kind of eyeball it with the scale here, see where I'm at, and then I have plenty of clearance now. This is the thing with these multitask machines. that spindle face is so big in diameter, you got to be careful with the chuck jaws when you're turning down to smaller diameters like this. And you only really had to make that pass in that little piece there, but it would have hit the chuck jaws really bad if I had let it take those passes. The finish tool, and that, not that diameter, but the next diameter, I need to hold that close because that lines up in the part's bore, and I want to hold that to a pretty close fit to the bore in the part itself. No more than 1/1000th of an inch clearance. So it looks like I got about 10 thousandths, a little more than 10 thousandths to go still. Take another pass at this. Yeah, I'm happy with that diameter now. Got it a little bit less than 1/1000th of an inch under the size of the bore is going to be. And this is just clearance for the key behind the drill guide plate, if you'll remember the other fixture. 1/2 inch 4-flute carbide anvil. And this notch here is really for the purpose of when I turn this thing, I saw it off this bar and turn it around, I can line up on what I've already done on this side. That's really what that's going to be for. I want to make sure my run out, nothing moved. I want to check it. Look pretty good. Because it's important for these holes to be in the right location on the face. Spot drill. Kind of difficult to see anything here. I was kind of trying to turn the coolant off and on so you could see that. So there's all the spot drills for the various holes. Here's a drill just to start some of the holes, and it's also the tap drill size for the middle hole, the 5/16 18 screw that holds the drill plate on in the middle. This is going to be the drill for the reamer, the drill before the .186 reamer for the pins. I got to mill counter bores to start the gun drill in. I'm not going to show you every single bit of this because it just, you can't really see too much with all that coolant, and I can't really run it dry. I did the first one, I tested it with a gauge pin. It's important that the gun drill actually goes in this hole. If it's too small, you'll break the gun drill. You know, because the gun drill is not going to be running or turning. It's going to go in there stationary, and then you'll turn the spindle on after it gets in the hole. And if the hole is too small, it'll break the drill. Bend it or break it or something. So here I'm checking to make sure the drills all fit in the holes that correspond to them. These are really just clearance holes so that the gun drill can come from the other side and match up to the drill plate, but they got to be in there. So this is a 5/16 diameter gun drill. 3 of the holes have this size. And I'm speeding this up just so you get the idea here. And I'm going to use the same tool holder for the next gun drill, so that's why I took it out there. And then we're going to come in here with the 7/16 gun drill and touch it off and drill all the holes. I'm just showing you the first hole, and here it rotates to the other side, and then the last hole. But it's basically the same thing. Now, that was the end of the day when I finished with that tool, so I came in the next morning and I just wanted to double check this to make sure everything was running true. It looked good, so I can continue. Sometimes the machine might cool down. It's been kind of cold here lately, and the machine might cool down, and so I want to double check that. 0.186 reamer for the press fit of the 3/16 dowel pins. And these tools I didn't have set up in the machine, so I just touched them on. And it's just reaming those two holes. Here's a 5/16 18 tap. Put some tapping fluid on. I have to do that before I close the doors because you can't run this machine with the doors open. So there's the dowel pins I'm going to press into the little holes there. So these are the alignment pins. And check both the plates to make sure they fit on there. So the next video, because I got stopped here because they had a rush job I had to go do on the horizontal mill, which is what I'm doing now. So the next video is going to be me machining these drill guide plates that mount on this fixture, and then I'll take the piece off and saw it off and do the other end of it. And besides, the video is getting kind of long here, so we'll continue this on the next video. So thanks for watching.